This third tutorial will cover more on defining functions, analyzing code, more on mesh operations, and while statements. You'll notice when you're working with model coding references to bpy.ops and references to bmesh, difference between the two boils down to the level of the code. By that I mean, for a real-world example, is like the difference between walking to a destination and flying to a destination. With bpy.ops, you're taking the slower route. It's less efficient route because it is part of the 3D view operations, whereas bmesh is much faster. That said, unless you're doing a lot of operations on a large processor intensive model, you probably do not even have to worry about the difference. And let's move our cursor to the center here. Now what I want to do is I want to create a plane, but I want to show you how to do it as a function. The value of functions are that you can, like if you want to do a lot of different operations, you can use for loops for functions and things like that. So they definitely increase your programming power. And if you use, for example, if you use 4 lines of code just repeatedly, you can just make a function out of it, and then it's only 1 line of code. So it changes things a lot for you. So what I wanted to do is I wanted to get this. I'm going to show you something here. So this is the code for making the plane, and what I want to show you is, you'll notice here it'll have enter edit mode equals false, align world, location, and that's a vector, and then scale, and that's a vector. But what I want to show you is this code came up like this, but if you go back to here and you hit tab, you'll get a lot more than what that code has. You'll get size. So then basically what I did to create the function for creating a plane was I copied this code and then went back here, put it in here with just what I wanted in here, and then we put in an edit statement and something for subdividing it, and then it's just modes again. Modes are kind of funny because sometimes when you're working with an operation, you might put in a line of code and then you'll switch back to the mode that you want to be in, and it still hasn't done anything. So then you have to switch to another mode. I think what it's doing is it's saving data or something like that. So anyway, when you're creating the function, you start out with def, def, then the name of the function that you want, and then the parameters. For example, let's see, sz. I just used sc. I guess you could probably get away with using size because I think I've seen somebody doing it before, but I just wanted to be a little different, so I put in sz for size. And that could be something like 1, 2, or 3. It's an integer. Subdivisions equals 4. That's going to be down here, right here. And then vLocation, that's right here. It's a vector, so it's going to look like that. You're probably wondering what these equal symbols are in here for. What they are is they're optional arguments. So, like when I run this thing, let's just do that. Put it in here and run it. Don't need that. If you get caught, just do something like that. It'll get you out of there. Alright, so that defines the function. So it doesn't actually do anything by defining the function, but you've defined the function, and you've got 1, 2, 3, 4, 5 lines of code. And then to run those 5 lines of code, you just go plane, and then put in your 3 arguments. Let's say we'll make it size 2 and make it 3 subdivisions, and then for location, oh, it doesn't have to be origin, it could be, let's just do it this way. Let's go 0, 0, 1. So it's going to be up a little bit. Hit enter. And then look, see, so it's not on the origin, it's actually been moved up on the z coordinate. And now the reason why you would put these optional arguments in here Maybe you just want to create a plane with 2, and you want it to have 4 subdivisions and to occur on the origin. So you don't have to, whatever you put in as optional arguments, you don't necessarily have to put the arguments in. So there. And it created it down on the origin because the optional argument is at 0. And in an earlier tutorial, I had a function here that changed the rotational axis. I took it and moved it to the origin, and that's what this is right here. So what I wanted to do is I wanted to show you how, if I wanted to figure out how code is working or analyze code, how you can do it. So for example, we have this function that says set origin, then it's got the parameters here. So let's see here, we can go, we want to define the object, so that gets the information from the plane here. And then let's go here. Alright, so we don't know exactly what this does, so I'm just going to put in MW and see what we get. Aha, we got a matrix. So we got the world matrix, and then let's go here, and this is going to throw an error, and I'll show you why in a second. Oh, it didn't. Oh, that's because I defined it earlier. It would have if I hadn't defined it earlier, but basically what happens is this parameter here, if you're just running these lines of code, and you can't, if you're doing analysis, you can't really run the first line of code, so you'd take this out and you'd go like this, and you, in order to define global origin, you just go like that. You want to see what MW inverted is. So then I'm just going to take, I guess I could have, no. Okay, so I'm just going to take this to see what MW inverted is. And so look here, this is positive, this is negative. And let's see, that's listed as negative, but that's just a 0, so that wouldn't make any difference. So it's doing a change on the matrix. I believe it's just an inverted matrix. And then on the next one, I'm not sure what this is going to do. Let's try it and see what it does. And then, oh, by the way, I forgot to mention in this last operation, this is the inverted matrix times global origin. And by the way, I didn't show you global origin, which is just a 0 vector. So it's just multiplying this inverted matrix times the 0 vector. The at symbol symbolizes matrix multiplication. Now it's setting the MW translation to global origin. So it's going MW translation. Oops. And it's changing it to this right here. And it moved it over. And then let's see. I don't remember what this is. Oh, okay, that's actually calling the function. That's what it is. So what we did is we analyzed this function just by going through line by line and seeing what happens. If you run into a for loop or something like that, you can just run the lines inside the for loop and change the parameters just enough to see what it's doing. I wanted to go over this first before we do anything else. Now we want to deselect object, and then back to our old principle of throwing an error to see what it does. Alright, so it's got select also. Select all. Alright, and then once again these notes will be along with the download for the tutorial. Plane. Okay, 2, comma, and subdivisions 5, and leave it at the origin. What that did is it deselected all of the faces. Alright, so if we wanted to do that again, only in step-by-step form to analyze it, first we need to have object. So say, let's see, we can go active object. But in this case, because it's using OB, we're going to use OB. OB. And then ME object. Alright. Let's make sure the object name is right. Okay. Alright, so that's getting the plane data, and that if statement would have fired because it does say plane there. And then we're getting B mesh. And then this is just going from face being numbered from 0 to 36. Now this is going to look kind of cool. So we know it's going to start out from 0 from that loop. So as I said again, we're analyzing, so we know that this is going 4, 0 to 36. So we want to start out at 0. And now it's not going to show, we're going to cheat a little bit because it's not going to show the results right away, and sometimes you might have to do that. And see what it did in the viewport? It deselected that face. So then we go up 2, we go face 1, then we go back to our update, face 2, update. So it's gradually just one by one deselecting the faces. And that's basically telling you what this does. That's how I analyze things. Now since I'm going to be using AO. And then you can find vertices, edges, and polygons in here. Hit tab again. Vertices is right here. Edges. Polygons. Alright, this kind of looks a little funny, but don't worry, it's going to turn into something pretty cool. Alright, so what we did is we got the active object, and then we got the vertices from the data, we got the edges, and we got the polygons for this. And now what we're going to do is we're going to use this to print out all of the vertices. And something's wrong because, oh wait a minute, no, because I think this was subdivided. Yeah, it was, okay. I don't want to use that one then. I just want to create a regular plane. I don't want to make things more difficult than they already are. Alright, So then I'm going to have to redefine this because we changed the object. But I want to make it simpler so that you can see what we've got here on just a simple plane. So what we've got is 4 vertices defined in the plane. One vertex is 0, one vertex is 1, the other vertex is 2, and the other vertex is 3. So you've got 4 vertices. And now I want to show you a trick that you'll find in the guide here. Just in case, like if you want to do it and maybe reverse it later on, you've got a reference on how to do it. Now if I can remember, let's see, so edit, go to preferences, go to interface, and then look for developer extras, click on that, and themes, 3D. Just in case you need to change it, let's see. The color is face angle text. It's right here. So if it's like too dark or something, then you can change it by going to themes and go to face angle text. Alright, and then we need to go up here and down to indices under developer here. Click on that. And after I clicked on that, you can see the numbers of the vertexes. And what's interesting is it goes 0, 1, 2, 3. 0, 1, 2, 3. Alright, and then edges. So you've got, let's see, 2, 0, that's an edge. You've got 0, 1, that's an edge. 1, 3, and 3, 2. 1, 3, 3, 2. And now, if we change this, like if I go back and re-enter this after I put in another object that's got more to it, then you're going to get a lot more out of it. So the bigger the object, the more complication you're going to find within the object. Now I'm going to copy all that, and then we're going to change the object to a cube. Alright, so you're seeing you're getting a lot more now. And then in edit mode, you see that the vertices have all their numbers to them, and we're having a lot of fun. Okay, so this was the instructions for showing the vertices, because it's alright. That's another way I can get the vertices. And then to get the coordinates. Alright, so I was having fun with that, and now I want to show you what I did with it. And this code is going to be in the file that I include, and you're probably going to want to save it somewhere where you can reuse it. So these are 3 different functions: get vertices, and let's get vert4. So what it did is it deselected everything except for vert4. So if, say, we wanted to edit a specific vertice using code, we can choose that particular vertex and edit it just by changing the entries for it. And then get edge, and I'm not sure which edge this is going to get. Let's see, probably, oh I know, let's do it this way. Select all. Alright, so let's get edge 6. Alright, so that edge is selected. And then get face. And let's see, what's our face numbers? Face 3, let's get face 3. So that's going to make for some pretty powerful tools when you are doing modeling via code. And modeling via code can be very handy because if you're doing an operation where you're repeating certain things, it can save you a lot of time. Thank you for watching, and hope this is all very useful for you.